Okay, I am doing now, Silvana. Okay, entonces now, square root negative 64, es obvio que es square root 64, pero contain I, es AI, the answer of this. Multiplication, 5i. Now you multiply f40 I squared. Yeah, I know very well que I squared is negative 1. So amazing. I squared, no imaginary. I squared is real. I, yes, I is pure imaginary. I squared, no. I squared is real. Therefore, the answer, you never leave it like that. Because you replace I squared for negative 1, and negative 1 times 40 is negative 40. And this is my final answer. Any question? Everyone follow me? Only say yes or zoom out.
Yeah.
Okay. Everyone? Nobody?
Yes.
Yes. Okay. Okay. Super. Let's move on. Example 2 and 3 is similar, but the only difference is that 2 we have 3 square root. And we are doing exactly the same. So this, some typical mistake is trying to put together this radical and only one. No, this is not good. So square root any negative quantity automatically is imaginary by definition. Okay, so you have this is 4i because the square root 16 is 4, no? The square root 4 is 2i, and the square root 49 is 7i. And you multiply 4 times 2 is 8, times 7 is 56, I to the third power. Okay, I to the third power, I know by memory also. If you don't remember, I can prove. Remember, this is a review. Any question you have, if you don't understand, I can explain, okay? It's negative I know by memory this. Because I at least I know by memory the first power of the I to the 1 power is I. I to the second power is negative 1. I to the cubic power is negative I. I to the 4th power equal 1 positive. And after that, I can derivate the rest of the power of the I using this partner. Okay, entonces you replace I cubic by negative I. Entonces actually the answer is negative 56I. Don't. Imaginary. That was real. That's no imaginary. Okay, everyone follow me? And number 3 is exactly the same, but we have 4. Square root negative 36 times square root negative 81 times square root negative 16 times square root negative 9. You compute separately one by one. This is 6i. This is 9i. This is 4i. Because the square root 16 is 4. And this is 3i. And now your multiplication, I do in my calculator, of course. 6 times 9 times 4 times 3. 648 I to the 4th power, because we have 1, 2, 3, and 4i. Yeah, I know that I to the 4th power is positive 1, and positive 1 is invisible multiplier. The answer is 648. Done. Again, real. You see, there's no coincidence. The even exponent are real. The odd exponent are imaginary. Okay, this is the regularly. Any questions so far? Well, so you understand very well this. I guarantee you have the first question of the test. The first question is similar to this. I don't know si es 2 radical, 3 radical. Of course, 2 or more than 2, no? Right. Number 4. Number practice now, 4, 5, 6, and 7 is a power of 5. I to the 15, I to the 18, I to the, sorry, 6, I to the negative 20, and 7 is I to the negative 9. So 2 using positive exponent and 2 using negative exponent. Okay, but I don't care. Remember the procedure. You take 15 divided by 4, always by 4. What is the reason it's by 4? Because the repetition of this panel is 4 by 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So when you divide by 4, you investigate in what column of the panel you are. Yeah, by the way, it's the column 3. Because 3 times 4 is 12. Subtraction is 3. Because in this case, I care the remainder. The important number is the remainder. This 3 is a coincidence. This 3 not always happen, of course. This 3 indicate us. This 3, the blue 3, indicate what group, what column, what column. Let me call column. What column? What column? You are. You are in the column 3 and the pattern. And this is the important information is the row. What row? This is the row. And the row is 3. So this is equivalent to say I cubic. Yeah, I know that I cubic is negative. Done. Final answer. Super. Likewise.
Can you explain how you got 12?
Say again?
I mean, not 12, not 12. Wait. Yeah, how did you get 12?
Good question. The reason is because, mister, see, you continue extending this part. Look, I to the 1 is high. I to the second is negative 1. I to the third is negative 8. I to the 4 is 1. We continue. I to the 5th power is exactly the same value. I to the 6th power is negative 1. I to the 7 is negative 8. I to the 8 is positive 1. Let's do one more column. Okay, the column, yeah. So I to the 9 is high. I to the 10 is negative 1. I to the 12 is to the 12, no, to the 11 is negative 8. And I to the 12 is 1. Let me do one more. This is column 0. Column, get it, the basic column, no? Column 1, column 2. Our number is located in the column 3. Let me show you. I to the 13 is high. I to the 14 is negative 1. I to the 15. Oh, this is our example, negative I. And I to the 16 is 1. So when you divide by 4, because repetition is 4 by 4, 4 elements in this array, 4 elements in this array, 4 elements in this array, 4 elements in this array. When you divide by 4, the column is given by the quotient number. The quotient give me what column, the column 3 in our case. And the remainder give me the information what row is row 1, row 2, row 3, exactly in that position. Okay, I know by reference that the row 3 is exactly this. Yeah, I know by memory that I cube is negative 8. Therefore, the answer is negative 8. Now it's clear, mister? So to avoid,
Got it.
To avoid this too long process, no. Suppose I put in the test I to the 450. You are doing this diagram? No. You divide by 4. Okay? And take the remainder. And that's it. Let's do it now. 18. 18 is exactly the same. You divide 18 divided by 4. And you try to find one number que multiply by 4. Give me close to 18, que I suppose que es 4, no? Because 5 is too much. It's 20. No. Entonces 16. And the remainder is 2. Entonces equivalent to I squared y ahí no que es negativo 1. Final answer. Any question? And the negative exponent is a little bit more complicated because negative exponent means reciprocal. So this is equivalent to say 1 over I20 positive, pero in the denominator. Okay, you take 20 divided by 4 one more time. F5 is 20, remains 0. Okay. 1 over I to the 0, que this exponent, I to the 0. So any number or any expression, anything, any raised to the 0 power is equal to 1. Entonces 1 over 1 is 1. Yes. Likewise, this is 1 over I to the 9. 9 divided by 4 is 2. Because 2 times 4 is 8, and the remainder is 1. This is 1 over I. I leave it like that? No, of course, no. In that moment, we have division. Division of the complex, or in the imaginary. One is real, and I is imaginary. Pure real, pure imaginary. But the division is always the same. It doesn't matter if it's pure or it's complex. You multiply by this conjugate, and the conjugate is negative. Top and bottom. 1 times negative I is negative I. I times I say is I squared. But this negative is this negative. The I times I is I squared. But I know that I squared is negative 1. The negative I divided by negative, negative 1. Double negative becomes positive is negative I over 1. The answer is negative. Okay? Maybe sometimes, depending on the problem, well, the majority of the scenarios, we need to perform division, but it's super easy division, no? It's 1 over I. Okay, any question, guys? Do you understand the power of I or no?
I'm sorry, can you run over that number 6 again one more time?
Absolutely. Absolutely. Okay, number 6 was I raised to the minus 20. The negative exponent means reciprocal. That part is clear for you, mister? The negative exponent, So in algebra, when you have, for example, a, not necessarily I, to the minus 4 is 1 over a to the 4. This is the interpretation of negative exponent. Okay, now you focus in the denominator, que es the positive exponent. And you discover that when you divide 20 divided by 4, I suppose that you remember that we divided by 4, the remainder is 0. So this is equivalent to say I to the 0. 20 is 0. And always 20. So do you see any exact multiple of 4, like a 4, like a 4, like a 4, look, 4, 8, 12, 16, and even, what is the next? 20, no? Is 1, the answer, right? So exact, I know by memory, exact multiple of 4, so I to the 20, automatically, not necessarily, is 1. And 1 divided by 1 is 1. There's another point of view to see the problem. Clear now?
Right.
Super? Okay. Don't hesitate. Good. I like that you ask me, okay? Because the test, no, professor, no, I don't want to know. It's your problem. I passed this class. Okay. We are doing number 7. Now number 8. Number 8 is super easy. Number 8 is, okay. Number 8 is addition and subtraction. Number 8 is addition and subtraction. Complex number. In this case, 5 plus 6i minus 1 plus 7i plus 2 plus 10i. I enclose on the parenthesis because I consider that this is a complex number number 1, complex number number 2, and it's a complex number number 3. So we have actually 3 complex numbers. And the first, use subtraction, minus, this minus, subtraction. And the second, addition. But I don't care because automatically I remove the parentheses. 5 plus 6i stay the same because default you're supposed to get this sign a positive, no? The second no, because the second you're supposed to get this negative red color is like invisible -1, and when you apply distributive property, obviously change the sign of the complex number 2. So -1, -7i. And the third no, stay the same, +2, +10i. And the rest is combine like term, exactly like a, you know, algebra, real. So we combine the real, I highlight in yellow color, is 5 minus 1 is 4 plus 2 is 6. 6 is real. And 6i minus 7i and 10i. When you combine this guy, 6 positive, -7 is -i, -1i, -1 plus 10 is positive 9i. Oh, what the hell? Okay, that's my answer. So far it's okay, guys? Entonces, wait. Let me warning something because I teach in this class 3,000 times. Entonces, in this kind of question in the test, some people, I don't know why apply FOIL. 5 times 1 is no multiplication. No, it's wrong. Okay, no FOIL. FOIL is multiplication. When you multiply, yes, you apply FOIL. But when you are adding or subtracting, no, remove the parenthesis with the corresponding sign and combine like a lighter. Number 9, yes. Number 9 is multiplication. In this case, you multiply 3 complex numbers. 8 minus 5i times 2 plus 6i times 4 plus 2i. And actually, we have A, B, C, 3 complex numbers. And what do you select first? You can select, if you want, A and B. Or no, if you want, you select B and C. Or no, or you select maybe A and C first. It doesn't matter. This is associative property. It doesn't matter what is the order you select. The answer is the same. This is the beauty of the mathematics. Okay. So now there are no reason to change the order. I multiply the first and the second. Why not? If you want, copy separately here. A minus 5i, 2 plus 6i. You FOIL. Now you FOIL because multiplication, and you consider the complex number like a binomial. So multiplication, 16, real. 48 plus I, imaginary, pure imaginary. Minus 10i, again, pure imaginary. And negative 30, I squared. Yeah, I know always I squared is equal to -1, therefore there are no reason to continue express it like that. No. Well, you automatically, is the way I prefer, erase this guy and replace by -1 and you change the sign. Or no, or some people, no, professor, I want step by step. Okay, no problem. 16 plus 48i minus 10i minus 30 and -1. So in the last line, 16 plus 48i minus 10i plus, because negative and negative together become positive. And you combine now real, 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 real. 46. And imaginary, imaginary is positive 38i. And this is the final answer? No, because I need now multiplication, this result, partial answer, times the third complex number que I totally ignore. This is the term of this guy. It doesn't matter the order. Remember, the multiplication is also commutative, and you write like that, or like that, and or Bauer. So you switch this guy, and the answer doesn't change. And one more time, you apply for it. Of course, using calculator, so now 4 times 46. I put in calculator, of course. I don't want to do by hand, not necessary. 46.
I think 30.
What does it say?
Wait,
38. Because it's 38, sorry.
Yeah.
Thank you. It's 38. So 48 minus 10 is 38. So you any mistake you see, you don't hesitate, you know, because sometimes I have lapsus. So 46 times 4 is 184. So I did the multiplication. 4 times 46 is in my calculator. Now 4 times 38. 38 times 4, 152. In this case, imaginary, 152i. 46 times 4 is 98, no? But just in case I want to check in, 46 times 2, 92. 92i. 92i. And finally, 38 times 2, 76. So this and this is 76. Plus 76 I squared. Okay, as always, when you are doing multiplication, appear I squared. I know I squared is negative 1. If you want, directly you replace like that. Minus 76. And now we combine real. 84, 184, 76, subtraction. 184 minus 76. 108. 108 is the real part. Wow, no yellow. 108. Okay. 108, 108, 108, 108 plus 152 plus 92. 244. Done. Final answer. Any question? One like that you see in the test, multiplication 2 or 3. Si es 2 is easier. Si es 3 is easy also, but it's a little bit more long. It's the only disadvantage. Pero no big deal. No problema, guy? Sure. Okay, then let's do it number 10. Number 10 is a combined problem que include subtraction and division. Okay, let's do it quickly because it's easy. Okay, look. 10. 10 is square bracket 4 plus 2i subtraction 6 minus 4i bracket divided by 2 plus 3i. According to the order of operation, we should do the expression. When it's a fraction, you manipulate separately if you want top and bottom. Totally independent. So you manipulate top and bottom. So the expression in the top is subtraction. So I copy. I forgot the bottom part. No, I don't care for a moment. If I copy 4 plus 2i, minus 6 plus 4i. Because this minus affect both inside the subtraction. This is the minus hand and this is the subtraction. Okay. So now I just copy and paste the denominator because I don't working with this guy. I are not working. Now combine like term. Let me see real. Okay. Is negative 2. Imaginary is 6. Positive 6i divided by 2 plus 3i. So I finish the top part. The top part is okay. Now multiplication. No, sorry, division. And the division is always the same procedure. Okay, explain one day, but I need to refresh your memory now. The procedure is you multiply by one smart one. Okay, is formed by the conjugate of the complex number in the denominator. So in the denominator we have in our current problem 2 plus 3i. Entonces, what is the conjugate 2 plus 3i? Is 2 minus 3i. It's only change the sign, opposite sign for the imaginary part. This is called conjugate. So in symbolic, 2 plus 3i conjugate is equal to minus 3i. Entonces, in order to doesn't affect my original problem, you divide, so multiply and divide both by the same number. It's obvious that this guy is a 1. This is a smart one. Because doesn't affect my problem, however, help me to do the division. Okay? The division is you multiply this guy together and you multiply this guy. And finally, we accommodate real part and imaginary part separate. And you FOIL if you want. If you want, you FOIL. 2 times 2 is 4. Look, 2 times 2 is 4. 2 times minus 3i is minus 6i. 3i times 2 again is plus 6i. And 3i again times 3i is minus 9i squared. I FOIL. Always I know by memory that when you multiply any complex number times its conjugate, the answer is real. And you see now here, the imaginary part is gone. Cancel out. And stay alive 4 plus 9. Why plus? Because I squared is negative 1, and another negative become positive, into the answer 13. Okay, I explained in class one shortcut to do fast. Because this is considered like a special problem. And you multiply 2 times 2, 4. 3 times 3, 9 plus. And forget about negative and forget about I. Don't. And always is valid, this is your shortcut. In the top, no. Why no? Because the top is no family. It's completely ordinary multiplication. So it's multiplication, let me use in different color. This and this is negative 4. Multiplication this and this now. FOIL, so our first outer is plus 6i. A plus, no? Yeah, a plus 6i because negative and negative positive. Now, using another color, 6i times 2 is 12. Right? And finally, 6i times negative 3 is negative 18i squared. Okay, I squared, I know okay, it's negative 1. If you want, in order to save time, erase this part, and this negative 1 affect this, become positive. Ready to combine like term. Real and real. F14. 18 minus 4, 14. So I copy in the top. 14 equals 14 is the real part. Plus imaginary, this and this. 18, I. And the denominator, 13 is real. And leave it like that, you can, but more elegant. This is cosmetic. You split this common denominator like that. 14 over 13 plus 18 over 13i. Boom. And this is the answer. Okay. Any question in this problem? It's a classical. In this case, I did a little bit subtraction in the top and after division. I promise in the test you see one question of the radical, exactly we are doing today now at the beginning, one problem of the power of I, one problem of the addition subtraction, one problem of the multiplication, I don't know, see 2 or 3 complex number, and one problem of the division. Okay? And that's it, complex number, no more complex number. Any questions so far? You feel strong in complex number or no? You feel strong? Hey, what's going on? Are you sleeping? How do you feel in complex number? Okay, sum up. Okay, good. Okay. Let's move on to the quadratic equation. In this case, 11, 12 is 2 problems we solve them by square root. 13, 14 we solve them by quadratic formula. And 15 and 16 is mandatory using by complete the square. Let's do it. Okay, the first is 11. 2. 11. 11 is parenthesis p plus 7 square equal 19. Okay, this is classical apply a square root. How do you know? Well, because somebody, not me, do the factorization here. I take advantage of this. You apply a square root here, both sides. Now I know, okay, power 2 and square root cancel out each other and stay only p plus 7 equal plus or minus, because you would never forgot that when you apply square root you have 2 solutions, plus or minus square root 19, and 19 is a prime number and we cannot simplify more this radical. 19 is just 19. Finally, p, solve for p is equal minus 7. We move 7 to the right hand side, plus or minus square root 19. This is one elegant way to express the final answer. However, I know that we have 2 solutions, no? Because this double sign plus or minus represent 2 values. Actually, the solution set, if you want, if you leave it like that, perfect, guy, is minus 7 plus square root 19, comma, minus 7 minus square root 19. I put it that way to clarify a little bit more, no? But it's the same. 2 solutions, 2 solutions. 2 solutions is exactly expecting in quadratic equation. And this is real. The solution is real, but this is irrational because involved radical 19 is irrational number. Any square root of the prime number is irrational. Square root of the prime number is always irrational number. Okay. Any question? That was 11. 12 is similar. Is p minus 10 squared equal to 100. Okay. Okay. Maybe one of you say, well, Professor, I can expand this express it in standard form and apply ABC formula? Yeah, you can, but it's too long. So the easy way, the shortcut, is square root. Why? Your identification, because the square power, somebody dedicate time to factorization the trinomial. Because I take advantage of this job. You apply square root both sides, be minus 10, because I know that a square power and a square root undo each other. S equal plus or minus. This is the detail important. Plus or minus square root 200. 200 no. 200 is no prime number. 200 we can separate. 200 is 2 and 100. And when you compute square root 200, it's square root 2 and square root 100 que esté. This guy is 10. And so far as p minus 10 is equal plus or minus, of course, 10 radical 2. So the radical stay inside the radical and 10 go outside the radical. So 100, but it's 10 outside. Finally, p is equal to 10 plus or minus 10 radical 2. And again, we have two solutions real. How do you know that it's real? Because no hay. Si no hay, que es imaginario. Imaginario es el que contamina, que es complex. However, when everything is no hay, it's because it's real. Of course, irrational. Again, similar situation. Two real, two solution real, irrational. Because radical 2 is irrational. Yeah. Any question? No? Okay, this is a moment. Okay, this is a moment to any question, any minimum doubt, ask me, right? Okay. Well, 13. 13 is easy, but it's another technique using the quadratic formula. Si no specification the method, you can select the method that you like. Si specification, no. You need to do, you obey the command. Okay, in this case, this equation is quadratic equation. How do you know the quadratic equation? These two indicate the quadratic. These two, this exponent degree 2, indicate also que es quadratic. Entonces now A is 1, B is 1, and C is 5. ABC. Ax squared plus bx plus c equal to 0. Be careful that our original equation is ready to express it in standard. Standard means right hand side must be 0. And also you organize the left hand side polynomial in descending order of the degree. Degree 2, degree 1, degree 0, because we have no x. Okay, so your identification perfect, who is ABC. And no fraction, no decimal, nice. Plugging in, where? In the quadratic formula. This formula. Who is B? 1. Just negative 1. Plus or minus the square root. 1 squared minus 4 times 1, que es A, times 5, que es C. Divided by 2 times 1. Okay, according to the order of operation, you must do the expression inside. Always, I explain that order. You focus in that. 1 squared 1. Es obvio. It's a 20. It's negative 19. Whoosh, it's negative when I apply square root, because my formula involved containing square root. This is I. And 19, you know, the prime number. Okay, that's so far we have negative 1 plus or minus I. Say again? How do you know what? Repeat the question again.
How do you get 1 minus 20?
Ah, okay. I try to do the operation inside the radical. Let me go back. This operation means 1 square is 1. 4 times 1, 4 times 1 times 5 is 20. Subtraction 20. Do you follow me?
Oh, I understand.
Okay. Negative 19. And square root negative 19. So this square root is this big square root, no? Is I square root positive 19. Okay, therefore we have negative 1. I bring down this negative 1 plus or minus I radical 19 divided by 2. You can leave it like that, you can, but much better, more elegant is separate the split, the common denominator when it's complex number. When it's not complex, no. But when it's complex, yes. Negative 1/2 is the real part because this part represents the real part, and this part, square root 19 over 2i, represent the imaginary. Final answer. Any question? Easy or complicated? Guys, this is important. I promise that we need to use the quadratic equation throughout the semester. Anytime. Okay? Let's do it 14. 14. Professor, is there supposed to be 2 answers? No. Well, okay. Okay, of course, in algebra, okay. This is the traumatic thing in algebra. I solved my problem. However, when I go to the back of the book to see the answer, I see it's different. No, it's not different. It's the same answer, but it's equivalent. Okay? So the only modification that you are doing is you are doing well. Of course, it's equivalent. And equivalent means in algebra twin brother. It's the same. Okay, the only difference is, cosmetic. Clear? Let's do it 14. Very well. It's important, Dylan. This is important question. X squared. So you have to take another advanced mathematical like a calculus. You see more clear this idea. You see, wow, I spent 2 hours doing this problem. However, when I go to the back of the book, I see another answer. No, it's the same, but it's equivalent. Maybe sometimes it's hardest to prove that it's equivalent, but no, in this case, no, in this case was easy. Okay. Any participation? This equation is quadratic, yes or no? Quadratic, yes or no?
Yes.
How do you know? What is the glue? Can you give me information that quadratic?
That it's order.
Say again, what is that? An order.
Yeah.
What do you see? What mean order? Order is exponent, no?
Yeah.
Okay, this is a good word. Nobody explain order. Order is another more complicated thing. But it's okay, it's exponent too. Super, that's the answer. My second question is, this equation is quadratic equation or no? Yes. My second question is expressed in standard or no?
Yeah.
How do you know?
Because saying 0. It's in order.
No, the polynomial on the left hand side is organized in descending order of the degree 2, 1, 0. Suppose que one student write like that: x plus x squared plus 1 equal to 0. It's quadratic, yes, it's quadratic. But this is standard, no, it's not standard because the polynomial in the left hand side is not organized in descending order of the degree. Okay? Entonces, sí, when you have this, Another possibility, another scenario. Look, x squared plus x equal -1. This is a quadratic equation, yes or no? Yes. This is already expressed in standard. No, no standard. No standard because right hand side is not 0. Okay, another stupid thing is x plus x squared equal -1. Wow, horrible. It's horrible, right? Okay, this is important. To the first step to determine who is A, B, C, you need to express the equation in standard. So now it's ready to determine that A is 1, B is 1, and C is 1. Everything is 1 in this example. Now you apply again the quadratic formula. Everyone follow me, guys? Okay.
Yes.
B is -1, B is 1. Sorry, but in the formula we have, one negative here that I need to respect. Plus and minus square root 1 squared minus 4 times 1 times 1. Everything is 1. A, B, C is 1. 2 times 1. Now let's do the operation inside the radical. And the operation is u squared. So the exponential is first. 1 squared is 1, no? 1 times 1. Minus 4 times 1 times 1 is 4. Subtraction is -3. And when you apply the square root, get the big one, but I put the small because I'm condensing. This is I radical 3. Again, it's I because the quantity inside the square root is negative. Therefore, the answer is imaginary, not real. Now, so far, the answer is -1 plus or minus I radical 3 over 2. Okay, more elegant, it's a split. The common denominator is -1/2. It's the real part plus or minus I radical 3 over 2. Some students ask me, Professor, you put it I after or before? It doesn't matter. 1/2 plus or minus radical 3 over 2I. Doesn't matter. And how many solutions we have to here? How many? 2. How do you know? Okay, we have 2. Plus or minus. So actually, if you want, you separate. This is the condensing way to express the solution. However, actually, it's -1, plus -1/2, sorry, plus radical 3 over 2I, comma, -1/2 minus radical 3 over 2I. Okay. Super, Daniel. Okay, this is my solutions. No mandatory. For me, it's perfect. See, you write like that. Worst scenario, you write like that. Okay, I understand. You have 100 points. In this case, you have 110 points. No, it's the same. Okay? Clear? Quadratic equation. No problem with the quadratic equation or quadratic formula. No problem. No? Okay. Now, let's do 15 and 16. Okay, it's mandatory doing by completing the square. Suppose, a warning now, some students, I don't care. No, I solve it by quadratic formula because I lie. No, you lie. I don't care that you lie. The command is clear. Solving by completing the square. If you solve it by quadratic formula and you get super good solution, you have 0 point. Because the method that I want to see is completing the square. Skip the 15. Sorry, no, 15. Clifford. 15. I copy 16. I don't know why. 15. 15 is x squared plus 6x plus, hello. 15 is x squared plus 4x plus 10. Equal to 0. So what is the procedure to do by completing the square? By complete the square. Okay, is you copy this exactly the same. You move 10 to the right hand side because 10 participate but not now, and you put a box here that complete the square. Entonces, what is the formula to complete the square? It's b over 2 square. It's a formula. And this give me a magic number. In our specific example, b is 4. This is a1, b is 4, and c is 10. You take b is 4. 4 divided by 2 is 2, square 4. It's a coincidence. Not always happen, but in this case, it's a coincidence because the magic number is 4. This 4 is this 4. Okay? So I copy 4. And when it doesn't affect the equation, so you adding in the left hand side artificially 4, and the right hand side you put again plus 4 in order to balance the equation. Now the equation is already balanced. Now we start. I know that when you create this using the magic number, this trinomial is a perfect square. A perfect square trinomial. What means that? Que the factorization actually is not two parentheses like it common happens, you know, it's only one because they are twin brothers. It's x plus 2 square. So actually it's 2. But it's a coincidence. So it's factorization trinomial, everyone knows, open two parentheses, put the variable, get xx, in this case 2 and 2, because 2 times 2 is 4 and 2 plus 2 is 4. And the sign is all because plus, they are twin brothers, therefore we can condense it like an x plus 2 squared. In the right hand side we have minus 6. Minus 10 plus 4. Now this is similar to the example 11 and 12 in which you are ready to apply square root. Because the square root allow me destroy this square. This is x plus 2 without square. This is equal plus and minus. Again, negative number inside the SI. Radical 6. And 6 is impossible. Simplification more because 6 is 2 and 3. They are no couple of the factor that we can eliminate. No. Leave it like that. Entonces now x alone, solve for x and move minus 2 plus and minus I radical 6. And this is the final answer. Two solutions. 99% of the time, the quadratic equation have two solutions. Not always. Sometimes have one solution. Sometimes. Clear with the complete square? One problem, I guarantee you, and specificate clear by complete square. So you solve it by another way, no credit. Okay, 16. 16 is x squared plus 6x plus 18 equal to 0. Complete square again. Okay, do it. What should I do? Well, I move 18 to the right hand side, like a minus 18. So it's x squared plus 6x plus a box. I need to find the magic number inside the box. It's equal to minus 18 plus another box. Boom. And b is 6. The formula is b over 2 squared. I know that. In our specific example, b is 6. 6 divided by 2 is 3. And 3 squared is 9. This is the magic number, 99. Okay, now I know that when you introduce artificially the magic number, this trinomial is perfect square, and the factorization is only one parenthesis, not two, que es x plus 3, because 3 times 3 is 9, 3 plus 3 is 6. and this is negative 9. Ready to apply square root both sides. X plus 3 without square is equal plus or minus 3i. Because square root 9, you know, is I, square root 3 is square root 9, and square root 9 is 3. Finally, so for x is equal to minus 3. This 3 gets real number. I move to the right like a minus 3 plus or minus 3. And again, we have two complex solutions. By the way, in this case, a little bit more nice. It's no fraction, no irrational. It's minus 3 plus 3. Any question, guy? How you feel? Strong to solving any problem of the completed square? It's the same procedure. It's the same. Go ahead.
Where's the when it's x plus 3 plus minus 3, where did you get that? Can you explain that step?
Absolutely. Look at that. In this case, Mr. Square root negative, square root. You see that part, right? Square root negative 9.
Yes.
Is equal. I detect it immediately. Oh, square root negative number side. Square root positive number. I know that square root 9 is 3i. I copy that. However, don't forget, when you apply square root method, it's the intermediate method and between complete square, you need to put mandatory plus or minus. Yeah, the rest is pretty easy. I move positive 3 to the right hand side like a negative 3, boom, and that's it. Clear?
Okay, I just missed where you moved the 3 to the right.
Okay. Yeah, because my goal, what is my goal? What is my target? X. You need to isolate X. Okay, one more. It always happens when I teach in this. We are doing to 17. And 18, 19, 20, 21, 22, 23, 25 is for the third day. Okay, entonces 17. 17 is a little bit complicated. A little bit. Because actually, if you look at that, c is c to the 4th power minus 5c squared plus 6 equal to 0. Okay, my question is, this is the quadratic equation, yes or no? Nobody asked me? Answer me? Yes or no? Some people say yes. Other people say no. All right, answer me. All right, I want to see you answer. Come on, use in the chat. No, sum up no. Sum up means que you are agree. A quadratic, yes or no? Yes. Okay, BP say que yes. Another opinion. Nobody have opinion. AWU, it say yes again. And the rest is agree. It's actually quadratic equation. Definitely. Wow. Well, you are totally wrong. It's not.
Because negative 1 and
No. Because okay. What is the most important detail of the quadratic equation? The degree 2. In this case, the degree is 4. 4 power. Dylan dice, no, professor, no. Because the degree is 4. Entonces no quadratic equation. This is a polynomial equation. Poly is okay. Polynomial equation is okay. And by the way, the degree is equal 4. And I know that when you have polynomial equation, degree 4, we have 4 solutions. When you finish this example, we determined 4 solutions. Not 2 solutions exactly like a quadratic equation. So actually, the answer is no. It's no quadratic equation. Another thing that maybe is confusing for you, que I explained in another class, is quadratic in 4. What means quadratic from? Well, it's a special equation in which you have two exponents, 4 and 2. And 4 is double twice 2. Somehow, using manipulations, we can transform it to quadratic equation. This is another thing. Pero be aware that this is polynomial, degree 4, and when you finish this problem, we found, or we discover, you find, or you determine 4 solutions. However, I take advantage quadratic from, because quadratic from means that we can do something to convert this equation to quadratic equation. And the something that we are doing is change variable. The most change variable in mathematics is u. I don't know why. Some people, when they change the variable, you assume u equals c squared. So you assume, suppose this is supposition, definition, my definition, because I want. You assumption, okay, u is equal to c squared. When I rewrite the new equation using the new variable, guess u, 6 stays the same. This is minus 5u, because c squared is u, and this is u squared, because this exponent is twice this exponent. And now this equation, yes, it is a quadratic equation. This one. However, this no. This is quadratic from. Do you understand very well the differences? Do you understand very well the difference or no? Guys, you follow me. Yes or no? This is review for the test.
Yes.
Okay. Okay, now we focus temporary in this equation. It's easier than the original. Entonces now, what do you want to do? Solving by factorization or by quadratic formula? ABC or no? ABC, right? A1, B is -5, and C is 6. Okay, let's do it. Entonces, minus B is the formula. I want to copy the formula anytime. Okay, I'm using, because I need to memorize this formula. Are you ready to memorize the formula or not yet? Everyone memorize the formula or not yet? Not yet, honestly, come on. Yes, no, yes. Okay, what are you doing, guys? You are sleeping. Yeah, you memorize. You don't need to copy again anytime you use in this formula. But just in case, I copy because I want to guide using the formula. No? Because the formula guide me a little bit, no? So it's -5. Look, negative together become positive. Plus or minus square root 5 squared, -5 squared. Minus 4 times 81 times 6, okay, divided by 2 times 1. Okay, let's do the operation inside the radical. -5 squared is positive 25. Any negative number when you square become positive. Now 5 times 5, 25. And this is 4 times 1 is 24. Subtraction is 1. And the square root 1 is 1. So far we have 5 plus or minus 1 divided by 2. I separate into pieces, the positive piece and the negative piece. This is 6 over 2 is 3. This is my first. And the second is 5 minus 1 is 4. Divided by 2 is 2. Okay, but this is the solution. No. This is the solution. Remember the history. We have a complicated equation. We are doing change variable, transformation. We convert to the quadratic equation. We solve the quadratic equation. Now we discover two solutions, 3 and 2. So I split the paper into parts. U equal 3. And U equal 2. But I need no U. I need Z. Get the original variable. Now what's the relationship? What is the relationship between? What is the formula que conecta U and Z? This one. My assumption. Therefore, I replace C squared equal 3. C squared equal 2. In this moment, we have two equations, two new equations. In this case are both quadratic equations because degree 2. But this is super elementary, straightforward because I can solve it using square root method. Entonces, C alone is equal. Please don't forget plus and minus radical 3. Anytime you find, take square root, you put plus and minus to solution. Likewise here, plus and minus radical 2. So the solution set consists in 4 solutions, plus and minus radical 3, and plus and minus radical 2. You can write like that, or to see much better how many solutions we have, you can write in that way. Radical 3 positive, radical 3 negative, radical 2 positive, radical 3 negative. Okay, curly bracket. Any question, guys? I promise in the test you see something similar to this. Quadratic equation, quadratic equation. Okay, let me try to only set out 18. Because I know 18 is super complicated. I suppose that I don't put in that super complicated. No. I know big bad guy. However, in the review, I know. Okay, any question in the 17 problem, guys? Are you clear or confused? Come on. Answer me. Clear? Clear, say. Good. Okay. Let's set out, analyze, but don't finish. We continue. That's the first problem we are doing third day. Okay, 18. Clear, Mason. Okay, Mason, no problem, I understand. 18 say C to the 6th power. Wow, what the hell is that? 152. Don't worry for the number because we're using calculator, no? C cubic minus 3,375 equal to 0. Okay, my question is a quadratic equation, yes or no? Quadratic. Yes, no. Definitely no. Because the degree is C. Es polinomio, ¿no? Es polinomio. Es poli. Yes. No, poli no. Dylan say no, poli no, professor. Es poli. Es polinomio. Come on, opinion. Yes, es polinomio. But what's the idea behind polynomial? Is que the exponent are a whole number. A whole number is 6, it's a whole number, 3 is a whole number, and here 0 is also a whole number. So the exponent in our problem is 6, 3, and 0. It's a polynomial. Entonces, okay. This is important to understand this because, see, I get the conclusion que es polinomio. Entonces, I know que any polynomial equation contain exactly the same. What is the degree? What is the degree of this polynomial? What is the degree of this polynomial? What is the degree? Answer me. What is the degree? 6 is the degree. How many solutions we get when I finish that problem? How many? In my hand. When I finish 6 solutions. 6 solutions. Okay? Okay, but one more question, the last one. This equation is quadratic in front, yes or no? Okay, is the confusing part for the student. My question now is quadratic in front. Remember, quadratic in front is the name to assign name one equation que is possible to transform it in order to convert to quadratic. Okay, using the substitution U. Substitution U. So the answer is yes or no? Because, okay, using your definition, okay, because 3 is, okay, exactly is the idea. Because this exponent is twice this, entonces we can, is yes, the answer is yes. Yes, it is quadratic form. Entonces now I am using U substitution. Entonces, what is the formula que connecting U and C? What is the formula que connecting U and C in this specific example? What is the formula que connecting U and C in this specific example? No idea? It's obvious, it's easy because always is a smaller exponent. You have two exponents and the relationship is double, twice. Entonces es U is C to the 6th power. No, it's C to the 3rd power. You take the smaller, not the big one. Okay, because you take this is 1/2. And entonces you introduce 1/2 exponent. Wow, crazy. Entonces, negative 3,375. I just copy the number. This is 152U. And this is double. This is double is a square. And this new equation now is a quadratic equation. Yeah, I can use in the formula of the quadratic. Do you see the transformation? Do you understand the transformation? Got it. Okay, do you understand? Okay, entonces this is very, very complicated because, well, the quadratic equation not complicated. I use a calculator, I don't care. You determine the U value, but when you get the 2U value, you want U2, you come back to this expression and we have another polynomial equation, degree 3. So we have 3 solutions for this, 1, 2, 3, and 1, 2, 3. In total, 1, 2, 3, 4, 5, and 6 solutions. Exactly we expect. This is the last class. Next class. Sorry. Okay. How do you feel? Option retake the exam? No, retake. Okay. The policy of the exam is, let me explain.